What is a Ka for a strong acid like HCl? So for this question, actually, the answer is in the question. Uh, well, it gives you a big hint of what we're dealing with. HCl is a strong acid. I'm going to actually underline and highlight it because that right there actually tells you what your Ka is. These are the things that you do have to memorize, but anything that's labeled as a strong acid means that it has a Ka is greater than 1 for strong acids. So with that being said, weak acids in the opposite end are where they're less than 1 but greater than 0. Why do we say this? That's because when it comes to strong acids, you can actually search up like an actual empirical theoretical number for its Ka, but once you have a Ka greater than 1, you are saying that it dissociates completely in a solution. As in, when you pour in some hydrochloric acid, you will not see HCl still floating in there in the aqueous solution. You actually see just the hydronium and the chloride ions. They have completely separated and done their part, and that's why it's frankly quite acidic, because of the fact that it's pretty much able to maximize all the hydrogens it has on the chlorine to make sure it produces the most amount of acid it can produce. So with all that being said, the reason why I mention this is because once you pass the Ka of 1, your Ka value becomes almost irrelevant, as you don't need to know what the Ka value is to be able to further solve questions of, like, you know, what's the pH of this amount of HCl. Like if I had a 0.5 concentration of HCl, okay, with the formula using pH equals to negative log of H3O, because we had 0.5 of HCl and we know it dissociates completely, we already know then that we have 0.5 of H3O. We don't need to use the Ka in order to solve it. Like so Ka is equal to products over reactants, so it'd be like H3O plus the conjugate base. In this case for HCl, it would be the Cl minus over the conjugate acid, the HA, which would be the HCl. But exactly, we don't need to use this because this formula here is typically used to find the concentration of the hydronium, so we can actually find our acid. But if we can just see from the fact that it's a strong acid that dissociates 1 to 1, we don't need to mess with the Ka formula actually, and, you know, solve with like quadratic equations and stuff. We can just simply say that the pH is going to be represented by a full dissociation from of the acid from the chloride ions. So all that is pretty much saying is that for this question here, the Ka for a strong acid, you are allowed to just answer it's greater than 1, because you don't need an actual value. Once you've said it's greater than 1, that's all the information you need to be able to solve questions when it comes to finding out the pH of strong acids. Okay? So in this one, they gave a theoretical number here. So what's happened here is that, as I said, the numerator is very large compared to the denominator. So in this case, for example, if we had 0.5 dissociate, so we have 0.5 over 0.5 over almost 0, because in a sense what's happened here is that, sorry, I phrased that wrong. It'll be 0.5, because that's how much dissociates if we had 0.5 moles of HCl, and this would be like almost 0, because what's happened here is that it completely dissociates. We have almost literally nothing left of it, which is why you can get such a monumental number of Ka, which is why we cannot use this, I guess, formula to try to solve for it, because you're almost divided by 0. and then that's why exactly once K is greater than 1, you can't really work with it anymore. So with all that being said though, exactly, I keep the answer because I think they're trying to ask for the relationship here, that a Ka for strong acids is greater than 1, and leave it at that. You are free to search up theoretical values as well if you want to further understand it, but you'll see that when it comes to strong acids, whichever strong acid you're searching up for, that Ka value will be monumentally bigger than 1. Alright, so now time for just a quick drink of water.